Welcome to another of my videos where I work through and explain A-level Physics multi-choice questions. If you want to try this question yourself, pause the video now. If you got the answer D, give yourself a pat on the back. Well done. If you want to see my explanation of how I found the answers, please continue watching. So, in the system below, a light rigid beam is pivoted at X, held in position by a string which is fixed at Y. The beam carries a load of 200 newtons. The load is moved towards X. Which one of the following statements is correct? Okay, so as the mass or the weight moves towards X, which of these statements is true? The tension in the string increases. No, the tension in the string is actually going to decrease. Let's think about pivoting the beam at X. And if we take moments about X, take moments about any point on that system actually, we can say that the anti-clockwise moment is going to be equal to, well, I should have said the clockwise moment is going to be equal to the anti-clockwise moment. Well, any moment is equal to the force times the distance from the pivot. So this mass is trying to turn the beam in a clockwise direction. And it's the moment it produces is its force, its weight, multiplied by that distance. So as it moves towards X, the clockwise moment it produces is going to decrease. The anti-clockwise moment is provided by the vertical component of the tension in the string. So that because the clockwise moment is going to decrease, the anti-clockwise moment is also going to decrease. Well, its distance doesn't change, so it must be the actual tension in the string and therefore its vertical component of that tension that decreases. So A is not correct. The compression force in the beam increases. Compression force is the force pushing the beam into the wall. Well, the compression force is produced by the horizontal component of the tension in the string. And we've already established the tension in the string is going to decrease. Therefore, the horizontal force produced by the string and therefore the compression force in the beam is going to decrease. The moment of the load about X increases. Well, we've already said that the moment the load produces about the point X is actually going to decrease. So that's not correct. And finally, the magnitude of the vertical component of the reaction at X increases. Yes, this is true. We can look at this just qualitatively. As the weight moves towards the left, we've already established the tension in the string and therefore the vertical component of the tension string is going to decrease. Well, the weight still needs to be supported. So as the weight moves towards X, that downward facing force, that weight of the mass needs to be supported by something. There's less tension in the string, so it must be supported by a larger vertical component of the reaction force of the wall. So D is indeed correct. There is another way of looking at this, and this is by considering the force triangle. We're told the beam is held in position, which I'm assuming means it's stationary, it's not moving, it's in equilibrium. And there are three forces acting on that beam. There is the tension in the string, there is the weight of the beam, and there is the reaction force from the wall. Now, because it's an equilibrium, if I put all three of those force vectors together, they must form a complete triangle. But if I now reduce the tension, keep the same direction, I'm going to reduce the tension and show it with a smaller force vector. I'm going to keep the weight the same because the weight doesn't change. So roughly the same length weight. Hopefully you can see that the reaction force gains a significantly larger vertical component. If you found this useful, please like and leave a comment below, and I hope you'll watch more in the series.